Next topic in the Unit 2 revision is comparison between synchronous motor and induction motor. Comparison between synchronous motor and induction motor. Synchronous motor and induction motor. Synchronous motor is not self-starting. It is self-starting machine. Three-phase induction motor especially. It is self-starting motor. Its average speed is constant. Average speed is constant. So its average speed is not constant. It is varying with respect to a load. Constant varies with load. Load increases, speed decreases. It can be operated at both leading and lagging power factors. Leading and lagging power factors, whereas so only lagging power factor operates at only lagging power factor. Operates at only lagging power factor. It is doubly excited machine. Doubly excited machine means two supplies are connected. One is to the stator and another is to the rotor. Doubly excited machine. It is only singly excited machine. Supply is only connected to the stator winding. Speed control is not possible. That means if speed is constant, no other speed control mechanism is not required. Speed control is possible. It is more complicated. Cost is high. It is simple and low cost applications. That's it. More complicated. So not self-starting machine. Again, self-starting machine. Induction motor is self-starting. So average speed is constant. Here the speed is not constant because it is called the synchronous motor. It can be operated at both leading and lagging power factor. It operates only at lagging power factor, and speed control is not required. So in induction motor, speed control is possible. So speed control mechanism, we have different kinds of the speed control methods. So speed control is possible by controlling NS is controlled by controlling number of poles and controlled by frequency and the speed. So the frequency and the rotor resistance rotor resistance is controlled, and supply voltage. So there are different kinds of the speed control methods are there in induction motor, like the poles are controlled. If poles are controlled, means NS is equal to 120 F by P. Na? So if poles and the speed is inversely proportional. If poles are increased, the speed decreases. So likewise, once while in the manufacturing of the induction motor, the poles are fixed, because once the poles are fixed, it cannot be changed. So number of poles is inversely proportional to the speed of the induction motor. So like the frequency is directly proportional to speed. If the frequency increases, the stator speed increases. The rotor resistance is given by the expression rotor current is equal to rotor resistance by rotor impedance. Rotor current and rotor resistance and rotor impedance. So the rotor impedance is inversely proportional to rotor current and the frequency, like this. And the supply voltage also, it is directly proportional to supply voltage is directly proportional to the rotor current. So in this method, different speed control methods are there in order to control the speed of the induction motor. So it is more complicated. Synchronous motor is more complicated, and the cost of the synchronous motor is high. And induction motor construction is simple, and the cost of the induction motor is very less. Okay, so this is the comparison between the synchronous motor and the induction motor. So it is self-starting and self-starting, not self-starting, it is self-starting. So three-phase induction motor is self-starting because of because of the rotating magnetic field. We know that how the rotating magnetic is created. The rotating magnetic field is created if the three-phase supply is connected to the stator winding of the induction motor, and the rotating magnetic field is created.